In this lesson, we are going to learn about phases, and then we look at how to draw phasor diagrams. So let's go ahead. So the question says that a 50 Hz source having a root mean squared voltage of 240 volts delivers a root mean squared current of 10 amperes to a circuit. The current lags the voltage by 30 degrees. A. Draw a phasor diagram for the circuit. And B. Express the voltage and current as a function of time. So let's look at how you are going to solve this question here. Okay, so what is a phasor diagram? A phasor diagram is used to show the phase relationship between two or more sine waves having the same frequency. That's what a phasor diagram is. It's like a graphical representation of the relationship between two or more sine waves having the same frequency. Let's look at how to draw phasor diagrams. Okay, so for this question, which involves a root mean squared voltage and then a root mean squared current, let's look at how the phasor diagram is going to be. So I'll draw the phasor diagram and then afterwards I'll explain to you how I drew it. Okay, so let's go ahead. So I have the voltage here to be equal to 240, which is what a root mean squared voltage. And then I have the current I here to be equal to 10 amperes. Okay, so this is the phasor diagram. So let's look at how we're able to draw it. Okay, so in this case that I have a voltage and a current, I used the voltage as the reference phasor. Okay, what you have here is a phasor with an arrow. Okay, that's what a phasor. So I use the voltage as the reference phasor, which means we are going to start measuring our angle from the voltage. Okay, so this reference phasor can take any angular direction. Okay, it can take any angular direction, which means that I can redraw this. I can redraw this phasor diagram as something like this. Okay, then I have my phase angle here. Okay, to go at 30 degrees. So I can draw it like this. So this will be the voltage and then this will be the current. Okay, so this is still my reference phasor. Okay, so it can be at what any angular direction, but I would advise that for things to be easier for you when you are drawing phasor diagrams for voltage and current, normally represent the reference phasor, which is what the voltage on the positive x axis. Okay, so let's say I have this here, this is positive x, this is positive x, and then this is positive y. So in that case, the reference phasor is going to be here. Okay, it's going to be here. Okay, so now I advise that you draw your phasor diagrams with the reference phasor on the positive x axis. Okay, so let's go ahead. Used the voltage as the reference phasor. Okay, I use the voltage as the reference phasor, and then I measure the current angle, okay, from the reference phasor. And then from the question, we told that the current lags the voltage by about 30 degrees. Okay, it lags the voltage by about 30 degrees, which means what we're going to read the current, the phase angle, okay, from the reference angle in the clockwise direction. That's going to be what, negative. Okay, so let's say if I have something like this, and then I have the reference phasor here, voltage, and then the current is lagging the voltage by 30 degrees. That means what, I'm going to measure the current in this direction. Okay, so I'm going to have, let's say, 30 degrees here, and then this will be what, the current, because what, it lacks the voltage. Should the current be leading the voltage, then I'm going to have the voltage here, then the current will be somewhere here. Okay, so this will be what, 30 degrees. So in this case the angle was positive, and then in this case here the angle is what, negative, because it is what, lagging. So one thing you should know is that anytime one quantity is lagging, then that means what, its phase angle is going to be what, negative, and then when it is leading, its phase angle is going to be what, positive. So you see that from this diagram that I have here, okay, I brought the phase angle here because the current is said to be what, lagging the voltage. That's how can I have this circuit here. Okay, and then one thing you should know is that the length of the phasor, okay, or the magnitude of the phasor represents the RMS values. Okay, so the magnitude of this phasor here represents what, the RMS value, which is what, the voltage, and that's what, 240, and same here for the current, which is what, 10 amperes. Sometimes the magnitude can be represented as the peak value of the quantity. Okay, so it's not always represented with the RMS value. Okay, so let's continue. So this is my phasor diagram for this circuit. Okay, so I have the voltage here, and then I have the current here, which is what, lagging the voltage by what, 30 degrees. So now let's go ahead and answer the B. So for the B, we have to express the voltage and current as a function of time. We have to express the voltage and current as a function of time. So how are you going to do this? Okay, so to do this, I'm going to write a general formula for this. Okay, so that will be, I have A of t, okay, equals A peak, okay, multiplying the sine of omega t plus, let's make it plus or minus phi. Okay, so this is the general formula. Okay, the phi here is the phase angle, okay, and the phi is positive when it is what, leading, and then negative when it is what, lagging. Okay, that's why I made it what, positive or negative. Okay, so when it is leading, I'm going to make it positive, and then when it is lagging, I'm going to make it what, negative. So the phi is the phase angle. Let me write this. Okay, so this is the general expression. Okay, so this is the general expression that we are going to use to express voltage and current as a function of time. Okay, so let's go ahead. So further explaining this expression, the omega is the angular frequency. Okay, let's answer the B part. Okay, so we were given the voltage and current in what, VRMS. Okay, so for us to be able to rewrite this as a function of time, you will need the peak voltage and then peak current. Okay, so let's look at how you are going to do that. So to do this, we know that VRMS is given as V peak or V mass over what? The square root of 2. And then IRMS is given as I mass over what? Root 2. Okay, if you don't understand how I was able to get this formula, then you can watch my video on how to derive the formula for the root mean squared of a sinusoidal voltage or current. I have the link in the description so you can check it out. Okay, so these are the formulas for the VRMS and IRMS of a sinusoid. Okay, so how are you going to calculate for the V mass? Okay, how are you going to calculate for the what? V mass and then I mass? Because you have to substitute them into the general formula that we have here. Okay, because in the general formula you see that we need what? A mass, right? Which is this AM here. Okay, so for that reason you have to calculate for the peak values of the of the quantity. Okay, so you have to calculate for the peak voltage and then peak current. So from this formula, the peak voltage V mass will be equal to what? VRMS times what? The square root of 2. Okay, and we know VRMS will be what? 240. So we have V mass will be what? 240 square root of 2. Same way, you are going to have I mass to be equal to what? IRMS multiplying the square root of what? 2. And you know IRMS to be what? 10 amperes. So that's what? 10 root 2. Okay, so we know the peak values. Okay, we know the peak values. Okay, so let's continue. Okay, so what you have to note down is the phase angle phi. Okay, so for the voltage, okay, let's make it 5V. That what? 0. Okay, that's 0 degrees. Okay, so the phase angle for the reference phasor is what? 0. Okay, and then that of the current, which are named phi I, okay, will be what? 30 degrees. And you know it is lagging, so that's what? Negative. So let's keep that in mind. Okay, so now that you know the phase angle, let's look at something here. Okay, so the angular frequency omega is given as what? 2 pi f. Okay, it's given as what? 2 pi f. So you can substitute this into the general formula. Okay, you can substitute this into the general formula. So let's do this. Let me clean this. Okay, so when I substitute this into the general formula, I'm going to have something like A of t equals A mass, okay, multiplying sine of what? Omega t, but I know omega to be what? 2 pi f. Okay, then bring the t, then plus or minus the phase angle. So this will be what the general formula now. Okay, so now let's go ahead and then find the answer to the V. So first of all, you are going to express voltage as a function of time. So that's what? V of t. Okay, so that will equal to what? V mass sine of what? 2 pi 2 pi ft. Okay, plus or minus what? The phase angle. But in this case, since voltage is the reference phasor here, it is going to have what? A phase angle of what? 0. So that would be like plus 0. But since it is 0, you can what? Ignore it. So I'm going to have what? 2 pi ft. Okay, so in the question, you've been given the frequency f to be what? 50 hertz, right? So now let's do substitution. Okay, so in doing this, I'm going to have voltage as a function of time to what? Vm. We know Vm to what? 240 square root of 2. And then sine of what? 2 pi f. So that would be 2 pi. I know frequency to be what? 50. So that was 2 pi times what? 50. Then times t. So and then we have what? V of t is equal to 240 square root of 2. Then sine of what? 100 pi t. Okay, 100 pi t. So that's what the voltage as what? As a function of time. So if express the voltage as a function of time. We are going to do the same for the current also. Let's look at how you are going to do this. So for the current as a function of time, I have I of t. Okay, I have I of t. Then this will be what? I mass or the peak value multiplying sine of what? Omega t plus or minus the phase angle. Okay. So this will give us I of t to be equal to, we know the peak value to what? 10 root 2. Okay. And then sine of what? Omega t, which will be what? 2 pi ft. And then plus or minus what? The phase angle. But in this case, the current is lagging, so the phase angle is going to be what? Negative. So that what? Minus 30 degrees. Okay, so it is lagging, so we are going to subtract the phase angle. So that what? Minus 30 degrees. So this will give us I of t to be equal to what? 10 root 2. And let's not forget the frequency. Sine of what? 2 pi times the frequency, which is what? 50 times what? T minus 30 degrees. So you have I of t to be equal to 10 root 2 sine of 100 pi t minus 30 degrees. So that will be the expression for the current as a function of time. Okay, that's how to go about this question. And also,